So Varsity Thomas comes out. Varsity burns. No C team burns. All right. And we are off to working on example 1, where we are given an algebraic expression to represent the verbal expression 7 less than a number. Okay, you'll find that within mathematics, anytime they're talking about you using a variable, they're always going to say less than a number. This is where your key terms come in. Okay, less than. It's telling you the operation is subtraction. Okay, or if it was saying the difference between a number and 7, we would be able to put a variable subtracting 7 would be our answer, and you can see that right there. Okay. Like I said, I got to kind of go through these verbal expressions kind of quick because we're short on time. But does that kind of make sense to everybody? How each word problem gives you clues about what to do. Okay, it really gives you clues. I'm going to minimize that. I'm actually going to just... There we go. We'll actually do the slides. Okay, so once again, example 1A, write an algebraic expression to represent a verbal expression, 7 less than a number. The answer is going to be any variable. They typically use n, but n minus 7 does represent that expression. It could be x minus 7. It could be a minus 7. It could be b minus 7. Whichever variable you choose, minus 7 would be a correct answer in this situation. Okay, looking at the next one. It's example 1B. It should be page 12, I believe, in the PDF. It says, write an algebraic expression to represent the verbal expression, the square of a number decreased by the product of 5 and the number. Okay, so the first term that jumps out to me is a square of a number. So a number tells me I need to have a variable, and square represents the exponent of 2, or x squared. Okay, so that's that first portion. The square of a number is x squared, or variable squared, and then decreased by, there's your key term again. So that means we're going to be subtracting by the product of 5 and that number. So the key thing is we're going to have two instances where we have the variable. We have x squared, and then we're going to subtract the product of 5 in that number. So we're betting that we're going to have x squared minus 5x. Okay, and this takes a little bit of time to get used to. If you don't have a lot of experience, especially with word problems, stop, slow down, and try to break it into its individual pieces, right? The first part, square of a number, okay, variable squared. Decreased by is your operation of subtraction, and the product of 5 and the number. Okay, so now it wants us to write an algebraic expression to represent the verbal expression of 6 more than a number. Okay, so more and increased kind of work hand in hand. They're synonyms. So a number, once again, represents a variable. So we're looking for an option that has a number increased by 6, or 6 more than the number. That should correspond to b, x plus 6. Okay, the next one. Example 1. This is number B. It's another multiple choice. It says, write an algebraic expression to represent the verbal expression 2 less than the cube of a number. They're changing. Go to the Zoom. This one is sweet. Had to double check to make sure that my slides were changed on Zoom. I would hate to be going forward and have you guys stuck on slide 1. That would be pretty rude. it would be kind of funny, but it's okay. So once again, we're looking 2, and then we have less than, so that's telling us that we're going to be using subtraction. The cube of a number corresponds to a variable to the 3rd power. So we're looking, and it's probably going to be a, x cubed minus 2. Okay, and these are why these verbal hints make a lot of sense, and they make your life very easy. Okay, here we have algebraic to verbal sentence. So they give us the algebraic equation, and we have to write a verbal sentence with that. So we have 6 is equal to -5 increased by a number. Okay, and you always want to say equal to because we have that equal sign. So 6 is equal to -5 increased by a number. Let's see how close we got. 6 is equal to -5 plus a number. Okay, so you can see the algebraic to verbal. It's basically the same context. Just make sure you're using your key terms. Increased by, more than, less than, difference, quotient, all that good stuff. Okay, write a verbal sentence to represent 7y minus 2 is equal to 19. Okay, so to tip that we have multiplication, there needs to be an instance where we have the product. To tip that we have subtraction, we need to say less than or the difference. We need to have equal to, and we need to have 19. So I'm going to actually do this backwards. I'm going to say 19 is equal to the product of 7 and a number minus 2. And they do it the simple way. 7 times number minus 2 is 19. Understand that with these verbal to algebraic, there's multiple ways to skin a cat. That's one of the beautiful things about English, is that you can say the same thing in about 15 different ways. Okay, a couple multiple choice. What is the verbal sentence that represents the equation n minus 3 is equal to 7? We have A, the difference of a number, and 3 is 7. Okay, that's a good one. The sum of a number. Sum talks about it, addition. And then it says the difference of 3 and a number is 7. Okay, their order matters. So we want to have what we're subtracting come first. So the variable's got to come first. And our answer here should be A. Okay, very quick, very simple. Like I said, I'm short on time, so I'm going to fast forward through a couple of these. That way we can get to this part. Should be looking at key concept properties of equality. Okay, you have the reflexive, symmetric, transitive, and substitution properties. The symbols, it says for reflexive, it says for any real number, A is equivalent to A. So in other words, a number is itself. It's reflexive. Okay, so A is equal to A. B plus 12 is equal to B plus 12. Okay, talking about equality here. Then you have symmetric. For all real numbers, A and B, if A is equal to B, then B is equal to A. So your example is if 18 is equal to negative 2n plus 4, then negative 2n plus 4 is equal to 18. The symmetric property is basically flipping the equal signs. Okay, it doesn't matter which part comes first. 18 is equal to negative 2n plus 4 is equivalent to negative 2n plus 4 is equal to 18. Transitive property is a beautiful property. It says that for all real numbers, A, B, and C, if A is equal to B and B is equal to C, then A must also be equal to C. Okay? So if I have two things that are equal and one of them is equal to a third item, then both of those are going to be equal. Your example of 5p plus 3 is equal to 48, and 48 is equal to 7p minus 15, then through the transitive property, 5p plus 3 must be equal to 7p minus 15. Okay, and then the substitution property of equality. This, in my opinion, is probably the biggest one and the greatest one. It's what allows you to substitute variables in and find solutions. It says that if A is equal to B, then A may be replaced by B and B may be replaced by A. Okay, in your example, if 6 plus 1 times the quantity of x is equal to 21, then 7x is equal to 21. Okay, 6 plus 1 is equal to 7. So they've replaced 6 plus 1 with 7 because those are equivalent statements. Okay, so identify properties of equality. Name the property that is illustrated by the statement a minus 2.03 is equal to a minus 2.03. They're the same on both sides. It's not telling us to relate two variables. We're not substituting in. And the order has not changed. So if the order changed, it would be the symmetric property. If it's stating that we have two items that are equal to a third item, that would be transitive. And then if we're substituting in, that would be substitution. So by the process of elimination, this should be the reflexive property. Okay, name the property illustrated by the statement. If 9 is equal to x, then x is equal to 9. In this situation, they're saying the same thing. It's just a matter that they flipped the order. So that falls into the symmetric property. Okay, example 3a says what property is illustrated by the statement? If x plus 4 is equal to 3, then 3 is equal to x plus 4. Once again, saying the same exact thing, it's just changed the order. So this is going to be the symmetric property of equality. Okay, what property is illustrated by this? If 3 is equal to x and x is equal to y, then 3 is equal to y. So the reflexive property is just stating the same thing, that a is equal to a. The symmetric property states the same thing, just changes the order. We're not substituting in, so from deductive reasoning again, we can say that this is the transitive property. Also, it follows. If we were to replace 3 with A and X with B and Y with C, it would match the transitive property exactly. Okay, so once again, there are your properties of equality. They are shown in your book as well. Okay, and they are shown on page number 6. All right, enough of the sentences. Let's get to the real stuff. Okay, solving one-step equalities. I've kind of lost count of the pages, but you'll be able to bounce back and forth. We're at example 4A. I'm going to take off the share so that you can see me work through. Okay, we're given m minus 5.48 is equal to 0.02. Okay, so when you're talking about solving any type of equation, you want to reverse your order of operations. Okay, one of the ways I use to explain it is PEMDAS. Please excuse my dear Aunt Sally. Order of operations, we would start with our parentheses, our exponents come second, multiplication and division from left to right, then addition from left to right. You guys should be very familiar with that because you've touched on it in Algebra 1. When we're solving those equations, we're going to bounce and work backwards. The only time that deviates is when we are dealing with a parenthesis. We're going to use the distributive property to take care of the parenthesis first, but then we'll reverse our order of operations. So in this sense, we have m minus 5.48 is equal to 0.02, and we want to focus on isolating the variable. So the way that we isolate the variable is we want to get it by itself. So if I have m plus m minus 5.48, in order to get this to the other side, I would have to add 5.48 to both sides. Okay, and one of the common mistakes is that you don't want to do it on both sides. Understand that whatever we do on the left side of the equal sign, we must do on the right side. Okay, so if we have a negative 5.48 and we're adding 5.48 to it, those are going to cancel out, and those are now gone. And m is by itself. And then 0.02 plus 5.48 is going to be equal to 5.5. So the solution that makes this true is 5.5. And the beautiful thing with math is you can always plug it back in to check yourself. We've just stated that m is equal to 5.5. If we plug this in, or m, into the original equation, 5.5 minus 5.48 is equal to 0.02, is that a true statement? And the answer to that would be yes, this is a true statement. Okay, that kind of makes sense. You're reversing order of operations, and don't be afraid to plug it back in, right? The simplest way to do that is to just check yourself. Okay, I'd hate to see you guys miss problems because we were too, not lazy, but we just didn't want to plug it back in because I'd rather be right than not tired any day. So m is equal to 5.5, and you should be able to see their reasoning and the checks on that PDF that I attached. So we are good with the solution of 5.5. And the next one, example 4, and it's letter B, and it gives us that we are to solve 18 is equal to 1/2 times t. Okay, 1/2 times t. So in the other words, we want to isolate the variable again. Here, my variable is t. I'm multiplied by 1/2, so I would have to divide by 1/2 on both sides. Okay, and the cool thing is that my 1/2s that are associated with the variable are going to cancel out. And then I have 18 divided by 1/2. When you're dealing with fractions, and especially with division, if you're dividing by 1/2, you're really, in all reality, multiplying by 2. Okay? Comes from a fraction where you have to flip to the reciprocal and multiply. So the reciprocal of 1/2 is 2/1. So if we do that operation, 2/1 times 18, or 2 times 18 is equal to 36. Okay, and then once again, if we plug it in, we plug it back in, 18 is equal to 1/2 times 36. 36 times 1 is 36. 2 times 1 is 2. Simplify my fraction. I'm left with that 18 is equal to 18, which would make this a true statement. Okay, so the key is when you're solving equations, we want to reverse the order of operations. Start with addition and subtraction to take care of those first, and then you can move into your multiplication and division, and then you take care of the exponents. Like I said, the only time that deviates is when you have the element of a parenthesis, which we will get to here shortly. I think it should be the next one. Okay, so I'm going to example 5, where it says solve a multi-step equation. And we are given the information that we are going to solve 53 is equal to 3y minus 2 times the quantity of 3y. So we're given this,